Good evening, class. My name is Betty Karimi, bed 050067/2021. I've specialized in mathematics and business. Today we learn more on sequences, and a sequence in a set S is a function from a certain kind of subset of integers into S. It will be assumed that the set of integers is non-empty or consists of consecutive integers and contains no largest integer in a particular domain of any sequence is infinite. Usually, the set of integers is either all non-negative integer or all positive integers. Sometimes the set of integers is all integers and the sequence in this case is often called doubly infinite. The value of a sequence f at the integer n is normally written fn rather than f into bracket n, and the sequence itself may be denoted by an. Expression like fn n less than or equal to 1, in which the outer subscript indicates the domain. A subsequence of a sequence f, which domain m or m plus m is a composition of m dot f dot n, where f is a sequence and n is a sequence in the domain of f such that nk is less than nk plus 1 for all k. For example, if n less or equal to 1 is a sequence, then a2k, k is less or equal to 1 is the subsequence, in which the function n is given by nk is equals to 2k. The domain of a subsequence by our definition is always infinite. A sequence an is a real number in a real number is convergent or convergent in a real number. If there exists a real number a such that for each element less to 0, there is an integer n with an minus a less than an element. For all n greater or equal to n, the number is necessarily unique and is called the limit of the sequence. Depending on how much information about the sequence is unambiguous, we may write lim n approaching to infinity, an is equals to a, or lim n an is equals to a, or lim an is equals to a, or an approaching to a. We also say that an tends to a as n tends to infinity. A sequence in a real number is called monotone increasing if an is less or equal to an plus 1 for all n in the domain. Monotone decreasing if an is greater or equal to an plus m for all n in the domain. Monotone if it is monotone increasing or monotone decreasing. Corollary 1.1, any bordered monotone sequence in a real number converges. If the sequence is monotone increasing, then the limit is there in the least upper bound of the image in R of the sequence. If the sequence is monotone decreasing, the limit is the greatest lower bound for the image. Remark, often it is corollary 1.6 rather than the existence of the least upper bounds. That is taken for granted in an elementary calculus course. This reason is that the statement of corollary 1.6 tends for calculus students to be easier to understand than the statement of the least upper bound property. Problem 1 at the end of the chapter asks for a derivation of the least upper bound property for corollary 1.6. We prove this by suppose that an is a monotone increasing and bounded. Let a equal to supremum n an, the existence of a supremum being ensured by theorem 1.1, and let element less than 0 be given if there were no integer r n with an less than a minus element, then a minus element would be a smaller upper bound, a contradiction. Thus, such an n existing for that n or n is less or equal to n implies a minus an element less to an less or equal to an less or equal to a less to a plus less or equal to plus n less or equal to n implies an minus a less to an element. Since E is arbitrarily lim n approaching infinity, an is equals to a. If the given sequence an is a monotone decreasing, we argue similarly with a infimum n an. In working with a sup and inf, it will be quite convenient to use the notation supremum x element ex when even when E is non-empty but not bounded above, and to use the notation and the notation infimum x element ex even when E is non-empty but not bounded below. We introduce sables positive infinity and negative infinity, plus or minus infinity, for this purpose, and instead the definitions of supremum x element ex and infimum x element ex to own an empty subset E and R by taking supremum x E minus x is equals to positive infinity if E has no upper bound, and infimum x element ex is equals to negative infinity if E has no lower bound. Thank you for your cooperation. That's all for today. Let's meet in our next class. Have a nice evening.